Welcome to this webinar about the 5th generation of National's Simple Switcher family.
Hello, I'm Ralf Regenhold. I'm the Power Management Technical Marketing Manager. I'm based in Europe in Fürstenfeldbruck.
And my name is Jürgen Kühnel. I'm the Technical Training Manager here in Fürstenfeldbruck outside of Munich. The agenda of this seminar is about the Simple Switcher 5th generation. We'll introduce the LM22680 family, including the LM22680. We'll talk about all the available options. We will give you an overview of the simple switchers and compare them to the 3rd generation simple switchers. You'll hear about the new TO263 thin package. And we give you a technical background on sequencing various switchers on a board. In this seminar today, we will only introduce the simple switcher regulators of the LM227x and LM22680 family. The LM315x synchronous simple switcher controllers and the new Webbench Power Designer are introduced in a different seminar you can find here on our website. The 5th generation simple switchers are meant up to 5 amps of output current and input voltage range up to 42 volts. For higher output currents up to 12 amps, please use LM3150 family, which is, as said before, shown in a different seminar. The simple switchers LM22680X. They are greatly improved over the 3rd generation simple switchers by having a much wider input voltage range, 4.5 to 42 volts compared to 8 volts to 40 volts. We added a 2 amp version. You can see here the 2 amp version. Additionally, we have now much higher initial accuracy and also overall accuracy of 1.5 respectively 2%. And we feature in this family a precision enable. What the precision enable gives you, we'll show later in this webinar. If you do not connect anything, the normal switching frequency of this part will be 500 kHz. But you can adjust the frequency in parts from 200 kHz all the way up to 1 MHz. Or you could frequency synchronize it from external from 500 kHz to 1 MHz. Adjustable current limit gives you the way to limit your output current to a certain value, like you take a 3 amp part, but you want to limit it to 2.5 amp, you can do so. We have an external soft start, very useful for parts that drive a lot of current, like the 2 amp, 3 amp or 5 amp parts. It is available with ceramic capacitors and it comes in 2 new packages. One, the TO263-7 thin, we'll explain in detail later, and a Power SO8 package which has thermal improvement over a standard SO8 package. All these parts will be available in Q-grade by the middle of 2009. So that is something when you are in the automotive industry to look out for.
Here we arrive at the block diagram of the simple switcher. All the simple switcher need an input capacitor as an energy reservoir to take the switching energy. They transfer this energy in the output capacitor. To have a regulation, the regulator needs an output voltage divider to feed the actual output voltage into an error amplifier. This error amplifier compares the output voltage with an internal reference. And then it goes through a type 3 compensation, which assures the loop stability of the device, into a PWM comparator. This PWM comparator is supplied by a fixed frequency oscillator. And this signal is going into the output driver, which drives the power MOSFET. This device has an internal N-channel power MOSFET. Due to the fact that it's an N-channel MOSFET, it needs an external bootstrap capacitor. The current is sensed through a sense resistor in a second smaller power MOSFET. This is not used for the loop, but is just used to detect peak currents and limit the peak current in case of a short circuit. Now let's come to the details of the features of the devices. Jürgen has already shown you all the available features all together, but not all the devices have them at the same time. Here, for example, we see the 0.5 amp devices and their features. The LM22674, for example, has just a precision enable pin. The 22671 has in addition a frequency adjust, at the same time synchronization pin and a soft start. Here we arrive to the 1 amp simple switchers. They have exactly the same features than the half amp switchers. For example, the LM22675 has the precision enable pin only. A more sophisticated device is the LM22672. It has the precision enable pin plus the frequency adjust and synchronization pin and the soft start. Here we see the new 2 amp simple switcher. It joined the family as a last one and we ran out of numbers, so we call this one LM22680. It features a precision enable pin, a frequency adjust pin, it can be synchronized, and it also has a soft start. Here you see the 3 amp simple switchers. We begin with the LM22676. It just has the precision enable pin. Then we move forward to the LM22670. It has the precision enable pin plus the frequency adjust or synchronization pin. And an alternative of this is the LM22673, which has a soft start which is adjustable by external resistor and also an additional pin for setting the current limit. To complete the whole family, we arrive at the 5 amp simple switchers. The LM22678 just has the precision enable pin. The LM22677 has in addition the frequency adjust and synchronization pin. And the third device has optional the 22679, the soft start or current limit setting pin.
For those simple switchers of the 5th generation, National offers a lot of tools. First of all, they are fully Webbench enabled for the new Webbench. Secondly, we have a quick start Excel-based tool that runs locally on your PC. Abbreviation boards are for general lab work. For reference designs, we have Gerber files. Those are EMI and noise optimized. There are application notes available indeed. And the list below shows you what abbreviation boards are available for which part. This is an overview of all the simple switcher products available from National Semiconductor. It starts down here with the 1st generation simple switchers running at 52 kHz, the 2nd generation running at 150 kHz, and the 3rd generation running at 260 kHz. The 4th generation is something a bit different because they are current mode compared to the voltage mode of the other ones. And here's my new generation, the 5th generation simple switchers. And the 5th generation simple switchers, as you can see, have the same part numbering as the 3rd generation, just a 2 in front. So replace the 2671 in future with the 22671 and so forth. The only part added is the 22680, which is a 2 amp version, which was not available in the 3rd generation simple switchers. Comparing in a bit more detail the 3rd generation with the 5th generation of the simple switchers shows that, for instance, a LM22675, a 1 amp version, can now be replaced with the LM22675. Those abbreviations in blue, the PE for instance, shows that this part has a precision enable now compared to the 2675, which has an enable. The difference is simply that an enable is a logic pin and a precision enable has a comparator. That comparator has a certain trigger point and that helps with sequencing. It will be explained later. Let us compare the 5th generation simple switchers over the 3rd generation in this more technical overview. As can be seen, the 5th generation has a much higher input voltage range from 4.5 to 42 volt compared to 8 to 40. Down there you see 500 kHz standard and adjustable to 1 MHz compared to fixed 260 kHz. There's a 2 amp version there. The accuracy is also better. Instead of plus minus 3%, we are now down to plus minus 2.5%. There is the precision enabled that was mentioned, and it has this new package, the 7-pin TO263 thin, compared to the standard 7-pin TO263, which is not a thin version. Okay, let's talk about the package. The new package is the TO263 thin, as we call it. The big advantage of it is it's halogen free and it's lead free, so it's a green package. Here is the outline. The old package was, and that is the main feature, 4.5 millimeters thick. The new package on the right hand side is just a mere 2 millimeters thick. So that's the main advantage of this package. The old one also has, on the so-called top end, another metal lid. The new one doesn't have that. Apart from that, the lead pitch and the width for both of these packages is the same. This is the landing patterns that you need to have on your boards. Left-hand side is the old package. You see that it is a bit differently shaped, like a T. On the right-hand side, you have the just squarish shaped landing pattern for the new package. But that doesn't mean you cannot mount the new package on the old layout. Here we show left-hand column, the new package mounted on the old layout, and it works very well. The right-hand side is the new package on the new layout. Fits better, indeed. But you can mount the new package on an existing old layout. That is important for everybody who does a slight revision of a product and wants to use the new product without changing the board layout and making a new PCB. In summary, the new TO263 thin package has several advantages over the older part. It is the same lead pitch, width and footprint. It matches with the old PCB layout. You can use the same handler for mounting, so no new machine, no new setup. It's halogen free and lead free. It's a green package. But most importantly, this package is now moisture sensitivity level 1. That means you do not have to have dry pack when you break up a reel and then only use half of it and want to restore the broken reel. The old part needed dry packing because it has moisture sensitivity level 3. And although not to be expected, the new package behaves better in terms of thermal performance. In this little table here, we show the TO263, the old package, having a thermal resistance of 23.6 degrees C per watt at 2 watt power. The new package at the same power is down to 22. That is a saving of about 5% better behavior.
Now let's go to some application examples. Sequencing. Why sequence power supplies? I will explain that in a few seconds. Then we'll go through the sequential startup of several buck regulators. We will discuss sequencing using the precision enable pin. We will discuss sequencing using an external power management device, the LM22880. And then we look at applications with frequency adjust and external synchronization. We will review in detail the sync functionality, and we will review in detail the adjustment of the frequency. Sequencing. Now let's have a look why sequencing is required. Specific power-on sequences are required, as an example, by microprocessors. They would need a monotonic ramp-up and they need a soft start realization. Complex multi-rail systems may have parasitic conduction paths. They also require sequencing for correct power-on behavior. This gives you a higher system reliability and it gives you a controlled power-up of all your system. Sequencing limits startup loading and high inrush currents. It reduces the power-on demand of the input bus and it reduces any input referred startup glitches on your input bus. Now let's look at the sequential sequencing using the Precision Enable feature of the device. Let's assume you have a FPGA needing two different voltages. One, a I/O voltage, second, a core voltage. The I/O voltage is starting to rise monotonically. When it reaches its nominal value, then you would like to start the core voltage. This is done by using two different regulators. The output voltage of the first regulator is feeding the I/O voltage. This voltage will be connected to the enable pin of the second buck regulator through a resistive divider. How do we get the threshold of the turn on of the second buck regulator? Simply use this formula and it will show you the dependence of the turn on threshold of the resistive divider and the internal threshold of the device. And this internal threshold voltage you will find in the electrical characteristics of the datasheet. It is typically 1.6 volts, but it has a minimum and a maximum value which is dependent on the maximum junction temperature, which goes from -40 degrees C to up to 125 degrees C. This diagram shows the usage of a power sequencer, the LM22680, to sequentially start three different buck regulators. The enable pin will start the supervisor to ramp up the first buck regulator. Then the second will come, then the third. The timing is optional. There will be an order code which determines this timing. It can be from 10 milliseconds up to 120 milliseconds. Let's have a look at the synchronization feature of the simple switchers. When do I actually need synchronization? Example would be the switching frequency of your buck regulator would interfere with other systems. Then you would like to adjust dynamically your switching frequency to an external clock. You would use the pin RT sync to connect to an external clock signal. With this you can influence the switching frequency of the buck regulator. There are some things which you need to take into consideration when you use the synchronization feature of the simple switcher regulators. The available devices for those features are the LM22670, 71, 75 and 77. Those are capable of synchronizing from a typical free running frequency of 500 kHz up to 1 MHz. The typical logic level high must exceed at least 1.75 volt. If you leave the sync pin floating, your buck regulator will switch at a default frequency of 500 kHz. Just know that the internal oscillator will synchronize to the external sync pulse with the rising edge. When you start your simple switcher, you must assure that the clock pulse is in a valid low or valid high state. When you synchronize to external synchronization pools, the LM227X family will not fold back the switching frequency in an overcurrent condition. If you don't want to use the default switching frequency of 500 kHz, you can connect a resistor from the RT pin to ground. With this, you can adjust the switching frequency from 200 kHz up to 1 MHz. The diagram on the right side shows you the switching frequency independence of that resistor. Please note that the Simple Switcher family internally set the mode of RT or sync during the startup phase. The Simple Switcher Regulator family have the feature of self-synchronization. You can run several simple switchers at the same switching frequency. To do this, you just connect the RT sync pins together and tie them to ground through a 1 kilo ohm resistor.
National simple switchers are featured in an own website. That website gives you all the details about the various simple switcher families, and on the right hand side it gives you the entry to the Webbench Power Designers. You enter your Vin range from min to max. You tell the designer what your output voltage and output current is, and you tell the designer what the ambient temperature in your equipment is. And then you go start the design and you go right into the Webbench Designer.